We're going to look at Venn diagrams with three sets and then set operations on Venn diagrams, or set operations on three sets, kind of all together here. So this video is a little longer than normal. First off, let's draw a Venn diagram for three sets. I'm going to start the same way I started before, except I'm going to try to make my rectangle bigger. I need some space to denote everything inside of here is in my universal set. Now, with three sets, I'm going to have to draw a Venn diagram with three circles. Now that's not too hard, but what is harder is I want those circles to each overlap with each other. And have some space that they don't overlap with each other. So what I mean by that is A needs a place where it can just have A stuff, which is right out here. It needs a place where it can just have stuff it shares with B and not C, which is here. It needs a place where it has stuff that it just shares with C but not B. And it needs a place in the middle here where it shares with B and C, where common elements to all three are. So you need three circles. You need them to overlap like this. They need to have all 8 of these regions in your picture. And now, to fill in this Venn diagram, I start in the middle. Always start in the middle. Look for elements that are common to all 3 of these sets. Well, is one common to all 3? No, it's only in A and B. Is 3 common to all 3? Yeah, 3 is in each of these sets, and it's the only one. Okay, now that I know what's in the very middle, I'm going to move out to what I call the fan blades. So if this were drawn better, these would look like fan blades. So I want to know what's in A and B. So in the intersection of A and B is 1, so I'm going to put 1 here, and 3. I already have 3 there, so I'm done with that spot. Now, what belongs in here? What is in A and C that I don't have yet? Well, A has 1, but C doesn't. A and C have 3, I already noted that. A and C both have 5 in them, so that belongs there. Finally, what goes in this space? Well, that's where C and B have the rest of their intersection. So C and B share just 2 and 3. I already have 3 noted, so I need a 2 here. My next step is to move out to just the spaces where the sets have their own elements that they don't share. So looking at A, I already have accounted for 1, 3, and 5. I need to put 1 in yet. And, nope, sorry, not 1. I need to put 7 in yet. I already had the 1. So I need to put 7 out here in A, right there. Now I have all 4 elements of A, 1, 3, 5, 7, and they're all in the right places. I now am going to move on to B here. What belongs out here in B? What does B have only to itself? The answer is nothing. I already have 1, 2, and 3, and that's all the elements inside of B. Next, let's look at C. C is supposed to have 2. It does. 3. It does. But then it needs 4, 5. It has, and 6. So I need to put 4 and 6 out in this area of C. Now I have 2, 3, 4, 6 in C. And I'm ready to go to my last spot, this outside area. What belongs out here? What's in the universal set that I haven't noted already? Well, I see that I've got the numbers 1 through 7 in the universal set. Down here I see 1, 2, there's 3, I see 4, I see 5, I see 6, I see 7. So in fact, I already have all of the elements in the universal set listed. They're all already here, they're all already where they belong. Now, the next few examples I'm going to do all work with this set. So if you want to get a little better at looking at Venn diagrams and trying to see where intersections and unions and things like that live, you might want to copy this picture down quick. All right, let's do some set operations. Set operations on 3 sets are no harder than set operations on 2 sets. because basically they're the same thing. The only difference is I might need to take more steps. If I want to find A union B intersect C, I see that B intersect C has parentheses here, so I'm going to start there. Let's find the set B intersects C by just inspecting. The set B has 1, 2, 3. The set C has 2, 3, 4, 5, 6. The only elements that are in their intersection should be 2 and 3. That's what they share. Now, I already have the set A listed here. It's 1, 3, 5, 7. And what do I want to do with those two sets? I want to find their union. So I want to find the union of the set containing 1, 3, 5, and 7, and the set containing 2, 3. So to do that, I just need to list everything in either one of those sets. From A, I've got 1, 3, 5, 7. From B intersects C, I pick up 2. I already have 3 listed. So there's my set that is A unioned with the intersection of B and C. It has the elements 1, 3, 5, 7, and 2. Or if you want to put that in increasing order, 1, 2, 3, 5, 7. What if instead I wanted to find, I have a typo here, sorry about that. In fact, it's important to point out, if I have a union and an intersection kind of lined up and I don't say which one to do first, I can't do the problem. It's unclear if I should do a union or intersection first, at least the way that we're going to be doing them. So I always need parentheses around if I've got a union and an intersection to say, hey, which one do you want me to do first? But now that I have those parentheses in there, I'm ready to go. I want to find A union B. Now I want to intersect that with A union C. So I start at the beginning, and I'm going to try to get these in order just for my own sanity. A union with B, I need 1, I need 2, I need 3, I need 5, I need 7. 1, 2, and 3 are in B, 5 and 7 are in A, so unioning them together gives me those guys. If I want to find A union C, I'm going to do the same type of thing. I see A has 1, C has 2, they both have 3, C has 4, they both have 5, C has 6, and A has 7. So there's A union C, 1, 2, 3, 4, 5, 6, 7. And now I want the intersection of these two sets that I just found. What is the intersection of A union B and A union C? Well, what elements are common to both of these? I see they both have 1, they both have 2, they both have 3, they both have 5, and they both have 7. So this intersection is 1, 2, 3, 5, 7. Okay, I was not able to fix that comma. It still looks terrible. But 1, 2, 3, 5, 7. Again, we just got there 2 sets at a time, find the individual pieces, and then put them together as requested. Okay, here's one with complements. So let's just dive right in. Looks like I need A complement. So that is everything that's in the universal set, but not in A. So looking down the line, the universal set has 1, so does A. Universal set has 2, but A does not. Universal set has 3, but A does. Universal set has 4, A doesn't. Universal set has 5, but A does. Universal set has 6, but A doesn't. And the universal set has 7, but so does A. So A complement is just 2, 4, 6 in this example. Now I need to find B union C complement. In order to do that, I'm going to need to find C complement, because that's what I want to take in union with B. Remember, that complement is stronger than the union, so I need to do it first. So C complement. Well, C has a lot of things in it, and if I look closely, let's see, 2, 3, 4, 5, 6, 1 and 7 are the only elements in the universal set that are not in C. Okay, now I think I'm ready to do B union with C complement. B is 1, 2, 3. C complement is 1 and 7. I already have a 1, so there's my 7. And finally, I'm ready to do what I was asked to do to start with. A complement intersected with B union C complement. A complement is up here. C complement, or B union C complement is down here. I want the intersection. I want to know what do those have in common. I see a 2. Let's see. I don't see 3 up here. I don't see 7 up here. So it would appear to me the intersection of these two sets is just the element 2. It's the only thing in both of them. Okay, just one more example here with these sets. I want to find A intersect B intersect C complement. Now, I do not need parentheses around A intersect B or B intersect C because the intersections, it doesn't matter what order you do them in. Let's just start at the beginning. A intersect B, or you could do them all at once, I suppose, especially if you're looking at your Venn diagram. But A intersect B is 1, 3. If I take that and intersect it with C, well, the only thing there is 3. There we go. Now, I don't want A intersect B intersect C. I want the complement of A intersect B intersect C. So I want everything in the universal set that isn't in A intersect B intersect C. In other words, I want everything in the universal set that's not 3. Well, everything in the universal set that's not 3 is 1, 2, 4, 5, 6, 7. There's some set operations on set operations on 3 sets. I hope you got what you needed to out of it. Thanks.